This is Accelerated Geometry, Section 3.9, Constructing the Centroid. So this is our last point of concurrency. In Lesson 3.8, we constructed 3 points of concurrency, and now in Lesson 3.9, we are constructing our 4th and last. This point of concurrency is called the centroid. The centroid is the point of concurrency of the 3 medians in a triangle. So they want us to construct the 3 medians in a triangle to actually see that they are concurrent at the centroid, that they all meet at the centroid. And then they want us to measure the distance from the centroid to the vertex and the centroid to the midpoint on each of the medians. So something special must happen there. Okay, so I'll bring this down. I've already started to do this. So over here on side AC, I created a perpendicular bisector, which allowed me to find the midpoint. Then I connected from the vertex B over to that midpoint. Okay, I did the same thing on side AB. Here I did a perpendicular bisector construction that allowed me to find the midpoint of side AB. A median goes from a vertex to the midpoint of the opposite side. So there is another median, and now I left this one for me to do here. So I'll go a little bit past the halfway point, create an arc, and from the other endpoint create an arc. I'll open up my compass a little bit wider and do the same thing from each endpoint. Now this point that I created is the same distance from C as it is from B, so it is on the perpendicular bisector of side BC. Same thing for this point here. So if those 2 points are on the perpendicular bisector, if I connect them, that will give me the perpendicular bisector, which allows me to find the midpoint. Now a median goes from the vertex to the midpoint of that opposite side. So all 3 of these medians come together at that one point called the centroid. Now they said, measure the distance between the centroid and that midpoint, and then between the centroid and the vertex. Look at this, 1, 2. So this was one of these distances, and up here it was 2 of those distances. Okay, what about this one? If I open up my compass that wide, that's 1. And now if I stab in there and go here and here, there's 2. So 1 and then 2. So it seems like the distance between the centroid and the vertex is twice the distance from the centroid to the midpoint. I found this here too. The distance from the centroid to the vertex is twice the distance from the centroid to the midpoint. And I bet you it's the same thing here. So this is the distance from the centroid to the midpoint, and then I can make 1, 2 of these up here. So that means the distance from the centroid to the vertex is again twice the distance from the centroid to the midpoint. So I think that is our conjecture. So if I go to the next slide, conjecture 15, the centroid of a triangle divides the median into 2 parts so that the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint. So here is a picture of that. From the centroid to the vertex A is 4.50. From the centroid to the midpoint E is 2.25. So the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint. And that happens on the other 2 medians also. So now we have 4 points of concurrency that you have to know. I made up this silly little slide here, which you can ignore if you want. It's just a silly memory device to remember all the points of concurrency. One thing you have to know before you do this is, if you look underneath the sink in your house or in the basement, you will see some white pipes. Those white plumbing pipes are called PVC pipes. PVC pipes. So you have to know that to kind of understand this crazy sentence. Mr. Centroid said orally, my PVC pipe is absent. Spelled wrong, but that's okay. Absent, I want it to be spelled wrong. Okay, so here is Mr. Centroid. I said P.S. Mr. Centroid was a poor speller because he spelled absent wrong. But here he is. Part of his PVC pipe is missing. It's absent. So Mr. Centroid, MR stands for made by medians, and it has a ratio of 2 to 1. Medians, ratio 2 to 1 in a centroid. He said orally. OR stands for orthocenter, AL made by altitudes. My PVC pipe, okay, P is perpendicular bisectors, V same distance to each vertex, and C circumcenter. My PVC pipe is absent, AB, S, IN, so have. The AB stands for angle bisectors. S stands for same distance to each side. And IN stands for in-center. So just some crazy little thing. You can just totally ignore this if you want. I just did that one day for fun. If you can come up with something better, please let me know. I'd love to change this one into something that's better. Okay, then there's one more thing left in this lesson 3.9, and that is an investigation. And it says, draw a triangle on a piece of cardboard, construct the centroid of the triangle, and then cut the triangle out. Using your pencil, see if you can balance your triangle on its centroid, and then complete conjecture 16 on your conjecture list. So you have a picture here of what happens. If you create this triangle on a piece of cardboard, and then you create the centroid, and then you cut it all out, it'll balance on a pencil. So if you put the pencil on the centroid, it will balance. Now, let's see if I can show you this. So I'm going to put this down. Let's see if this works. I'm going to move this up. I'm going to close these so it's not so sunny. Then I'm going to go over here, and I have to change the orientation of my camera. Okay, so now here is my cardboard, and it's very dark in here, but there you can kind of see that I did find the centroid. And now if I balance, there is my pencil, and there is my triangle balancing on that centroid. Okay. Now, the next slide shows this completed conjecture, and this is what it says. Conjecture 16. The centroid of a triangle is the center of gravity, the balance point of the triangular region. So there again is pictures of two people balancing their triangle on the centroid of the triangle on that end of the pencil. So I hope you enjoyed this lesson. It's kind of fun. And that is the end of lesson 3.9.